So in this question, we have got a polynomial. So we have x to the power n, where n is greater than 2. So maybe a cubic. So let's write down a cubic equation, for example. So it's like cubic is x cubed minus a3 x squared plus a2 x plus a1 according to the format given in the problem statement. So as we can see that if the roots are, they're saying positive roots, right? All the roots are positive. So if the roots are, let's say, PQR, okay, are the three roots, all are positive. Then we have A3. So sum of the roots is negative B over A. So A3 is basically P plus Q plus R. Okay. So sum of the roots is P plus Q plus R. Sorry, this is plus. So minus A3 is P plus Q plus R. Okay. Because sum of the roots is minus B over A. And B here is the second term in this case. The A is the first term. Okay. So minus of A3 over 1. So this is what we have. Or in other words, we can clearly from here say that A3 is negative of P plus Q plus R. So A3 is less than 0. So point number 1. Next, we know what is A2, that is the two roots product taken at a time and then we add. So basically A2 will be PQ plus QR plus PR. Clearly it's a product of two positive terms and their addition must be positive. So sum of the roots taken two at a time is positive A2 over the first coefficient, that is 1 in this case. So from here A2 must be greater than 0. That's point number 2. Lastly, the product of the roots PQR is basically the negative of the last coefficient over the first coefficient. So it is minus of A1 over 1, or in other words, PQR is obviously a positive quantity. So A1 is negative PQR. So we get A1 less than 0. So that is point number 3. Now, let us look at the statements one by one. So in this case, first option will be read as A3 cubed is greater than or equal to 3 cubed times A1. Now, A3 cubed is a negative quantity. You are saying is greater than A3 being positive and A1 is also negative. So it is in this case 27 times a negative quantity. Now, this is subject to what the actual values of the roots PQR will be. Okay, so I can always choose, observe that A3 is basically sum of the roots and A1 is just the product. Okay, so if one of the roots were 0, then the product of the roots will become 0. Okay, so this will become 0. As A1 will become 0, but A3 will not become 0, it will remain negative. So we'll have a negative quantity greater than or equal to 0, which is false. So it might be true, it might be false, it depends on the actual values of what the roots are. So we can eliminate the first option because they're saying necessarily true. So 1 is not correct. So let me remove that. Now let us look at the second option. It says 3 cubed is greater than or equal to A3 cubed times A1. Now A3 cubed will be negative and it will be a big negative because you're cubing a negative. A1 is also negative. So product of the two negatives will make it positive. So we are saying that 27 is greater than or equal to a positive quantity, which might happen, which might not happen. Again, that would actually depend on what the values of PQR are. And just because it is a cubic, we should not think of like the 3 has a really role to play in the values of A1, A2, A3 like that. Okay, so this doesn't look very likely. Let's keep it on hold for a minute. Now let's look at the third answer choice. So it says AN, so in this case A3 times n minus 2, so that's A1 greater than A3 times A2. Now A3 we see is common to both sides, but A3 is actually a negative quantity. So if I divide this whole thing by A3 and strike that A3 out, I will end up A1 less than A2 because the inequality will reverse. Now, A1 is less than A2, that is true because A2 is a positive quantity and A1 is negative. So A1 will always be less than A2 and this is definitely true. So we have got the answer as option 3. Now you can supplement this by actually taking some roots like 1, 2, and 3 and verifying whether statement 3 is coming out to be true or not. But that's not necessary because very logically we have seen that it has to be a true case.